Good morning, good afternoon, everyone. I'm here today to tell you all about the past year and the progress I've made to make a valuable impact in misinformation research. Imagine you're at a pizzeria in Washington, D.C. Suddenly, an armed man walks into the pizzeria and starts to fire his gun right at you. After ducking for cover, you overhear the shooter saying to the police, "I had read online that the pizzeria was harboring sex slaves, and I really wanted to see if they were in there." This is a real example that happened in DC at Comet Ping Pong Pizza, otherwise known as Pizzagate. This is only one out of many destructive outcomes that results in the spread of misinformation. These destructive outcomes will get worse unless researchers are able to find ways to avoid such events from taking place. This is why we all love data. Data is used to help us solve problems. Large data sets can provide more insights than smaller ones. However, creating large data sets is a daunting and time-consuming task, and most researchers lack large data sets to support their research in misinformation and disinformation. AMPER is an automated pipeline whose goal is to provide researchers with large data sets by continuously collecting news articles from multiple sources and stores them in a metadata repository. AMPER can be easily extended to feed the data into tools like Tableau Desktop to visualize the data, or tools such as AWS Ground Truth to create labeled data sets for machine learning algorithms. The pipeline retrieves documents from multiple sources at a regular interval and stores documents in a data lake. Sentiment analysis scores and classifies each document to measure the author's attitude towards a particular subject. Sentiment is usually classified into three categories: positive, negative, and neutral. The sentiment and other metadata attributes about each document is stored into the data lake and pulled into the metadata repository. The metadata repository is used to access the data within the data lake, and queries are used to retrieve the metadata to visualize it. The automated pipeline is implemented in Amazon Web Services, otherwise known as AWS. It has an event-driven architecture that uses events to trigger and communicate between AWS services. Time-based rules were used to trigger events to execute web scrape functions in AWS Lambda. These functions scraped and pulled Joe Biden articles from two sources. News articles were stored as JSON files and stored into AWS or Amazon S3. Each JSON file triggered another function that determines the sentiment of the article and puts the response back into S3. New metadata, including data source, the file name, title, author, and sentiment, is pulled from S3 and updates the metadata repository in AWS Glue. AWS Athena was then used to access data in the repository using SQL and perform exploratory analysis. Deeper analysis was done on the data using Tableau Desktop. The unexpected challenges in building the system includes finding data sources that do not require a paid subscription. Many APIs nowadays now require its users to pay for data, which can be a major drawback for researchers in terms of their budget or grant. AWS Lambda is a compute service that requires a huge learning curve. However, the benefits of using Lambda pay off over time. And one of the main challenges for this project was focusing on a specific topic in such a hot and new research field of misinformation. There are many unknowns still left to discover, which made it difficult to choose just one topic. The takeaways I want to present to you today are that data is used to help us solve these complex problems in misinformation. And AMPER is a way to provide researchers large data sets they need to support their research efforts in misinformation and disinformation.